So I was trying to come up with an idea for a presentation, not knowing what sort of people are going to be attending. So I wanted to make it something a bit fun, and at work I'm sort of working on big commercial applications. So I wanted to show that Postgres is quite good at home and smaller businesses, something you can play around and have fun with. So amongst some other hobbies, I'm also an amateur apiarist or beekeeper. So that's a few of the hives I've got running at home. I got into this because of you might have heard about the big decline in the bee population worldwide through pesticides and enemies like the wax moth, and there's varroa mite coming out here. And the other reason is you get this cool stuff here out of the honey. So I brought some of the best honey in Queensland along. It's out of my hives there, so I'm going to give some of that away to the most of the best questions, the easiest questions for me to answer. So anyway, so I thought I'd do it around the bees. So I was sort of coming up with some ideas. And I had this real problem as a apiarist in that to get the honey out of the hives, I've got to pull them all apart, and it's a really big disruption to the bees, and basically stop production for a day or two. So I thought it'd be good to write something and store the data in Postgres that I can see when it's time to go and rob the bees of their honey. And it's a lot of my time if I go in and they haven't capped the honey, because if they haven't capped it, it ends up very bitter, and I have to put it all back together. It's a big disruption and wait a couple of weeks. It's a lot of my time as well. So I was thinking, well, I can measure the weight. I could go out there and I could put some scales under the hives. Each one of these boxes, what we call a super, weighs about 25 kg when it's full of honey. So it's pretty easy to tell when they're full and ready and when they're not. But as well as just being able to monitor when to empty them for honey, I want to be able to tell what's the condition of the hive. Is it healthy at the moment? Because I have to go in at the moment, have a look and make sure there's no grubs from the wax moths. What other things can I measure besides weight? So there's temperature, humidity and noise level. The bees actually regulate the temperature of the hive at about 31 degrees Celsius. So if we deviate off that, I know there's going to be a problem with the hives. So I thought this could be good fun. So I've heard of the Arduino stuff. Who's played around with Arduino? Not many people. It's like, you've probably heard of the Raspberry Pi though. So that's like a service-mounted chip sort of mini computer. The Arduino is more at a slightly lower level. You're playing with the microcontroller. You can program the various sockets. So I put this thing together. You can get the sensors really cheap, like a couple of bucks. So I'll pass a few bits around. You can have a look. You can get like LCD screens. That's a board. There's a sensor there. I'm going to pass some down. That's like a little noise sensor. It's 99 cents. And a battery backup. And they're not too bad. They come with this is an Ethernet board, so it's got an Ethernet connector and a little reset button and an SD card. So I could program this to read all the sensors, store the data on the SD card, and then whack it into my computer and use Excel, sorry, LibreOffice to graph some of the data or some other visualization tool. But I'm a bit lazy. I don't want to go out there and do that all the time either. And I also want to log the data over a period of time. So I thought, great, can use Postgres. Don't have to spend lots of money. Oracle would be a bit overkill. But I've only got 10 hives, so wouldn't be worth it. I don't think the sales and honey would make the license fees. Okay. So then I got thinking a little bit further, and I'm also, I don't know if I mentioned, I'm a member of the Brisbane Amateur Bee Society, so there's other members around the area. So I was thinking, well, I could share the information with them. They'd be interested in doing something like this and logging details from their hives as well if I could make some sensors available. So I dug into Internet of Things, how we pass data around from sensors across the internet. And I looked at a couple of protocols I found. Does anyone play with IoT stuff, sensors? I noticed there's a couple of, I saw a couple of profiles that went along to the meetup for Internet of Things. Anyway, there's a couple of protocols around. There's COAP and MQTT, which is message queue telemetry transport. It's like a cut-down version of HTTP. It's much more efficient, but it's a publish-subscribe, and there's quite a few message brokers. There's the Apache message broker as well. You can download and run locally. There's also a C library available for the Arduino that you can, a client that you can publish and subscribe to a message broker. And there's also a Payho MQTT client available for Python. So with that combined with PsychoPD2, you've got access to that and your database. So that was what I designed to put together. So I just sort of wired up this this thing, I'll plug it in. It's a very simple interface, the IDE that comes with it that you can download for free. Hopefully you get some lights come on, waiting some power. There we go. So I'll bring up the IDE. There it is there, and it's very simple C code, hopefully you can see that. So include the libraries I need, there's a couple of IP addresses, define the pins that I want to talk to, so there's a digital pin 2 and an analog pin 0 that correspond to where some of these wires are plugged in on the board. And basically you can just read the data from the pins, check for some errors, and then I put together a bit of a JSON string that I'm going to send through or publish to the message broker using what they call a topic. So it's a bit like a RESTful API. You specify a topic. Here I'm saying Hive sets the data, JSON 1, and then I'm sending the data through to that. So I'll upload it to the device. That'll upload and run, and then there's a little utility called a sensor monitor, a serial monitor here. I'll clear in a minute. Okay, so that's running now. We can see, we're getting the could not send because I'm not actually running the message broker at the moment I'm subscribing to. I'll start that in a minute, but we can see some of the sensor data coming through. The sound's coming through as an arbitrary number, 36, 37. And then we've got our humidity and temperature. So you can see it's pretty warm in here. It's only 21 at my desk. So if I breathe on it, and I keep my fingers crossed, we should see those numbers go up a little bit. Yeah, so we've got an increase in humidity. We'll probably go up a little bit more on the next one. Okay, so that's basically publishing through to the message broker. And I've created a little VirtualBox VM here. And I'll run up the message broker. So 1885, and we can see the client is now connected. Comes with a couple of client utilities. I'll run up. So here I'm just subscribing to the message broker as another client and subscribing to that topic that I'm passing through and sending the data to. And you can see this data's coming from the device here. So if I open up the device, you should see the numbers correlate, sort of 98.3% humidity and 26.4 is the temperature. Okay, so that's getting the data from my sensors out of the hives into a message broker using an internet protocol, IoT protocol. Just might get a full screen. A little bit easier. I'll disconnect this at the moment because what I've done is I've just created a little test program with Drone. Drone, if you don't know, is the name for a male bee. It's a very lazy bee that doesn't do much in the hives. The workers are all females. We've got a queen, so I sort of named it after that. So the test program I decided to write because otherwise I'm going to get very boring information out of this. It's pretty much going to be static. So this just simulates a few different hives where I still connect to an 1885 on this VM, and there's some ranges in there that basically put together and publish some JSON type strings to the message broker. So if I run that up, we should still see data coming through here from this program. So we've got four different measurements: temperature, humidity, and noise. So pretty straightforward so far. The MQTT message broker, it's an old Apache project if you want to play around with it. It's in most of the repositories. I'm running CentOS, so it's easy to install using Young, and it's really easy to configure, run up. Okay, so now I've got that bit going. People can subscribe to the data online if I made that available, and they can grab that data and use it how they want. So I've written, so to get into the database, I've just written a little Python program again called Worker. Uses PyPG2 and that payload MQTT client that I mentioned. Pretty much we subscribe to this topic, doesn't matter which sensor, and then the callback gets called on message every time something every time we get notification. And basically I'm just inserting into a table called queen data. I'm supplying the sequence because I've written a little Django app so that you can go in and you can put more static data like the hive, the ID of the census and details about the location. So it generates an int as the feed, so you've got to manually populate that. So I'll just run the worker up so we're actually putting some data into the database. So we're now subscribing and it's inserting some of that data into the database. Okay, if we go to the database and have a quick look now, let's run up SQL. See, I'm running 9.6, the development version of PostgreSQL. I did have a little issue with some of the things, but hopefully it'll be okay. Call the database hive. If I describe some of the tables in there, you can see there's a lot of Django related tables in there, but the one we're interested in is queen data. Names it with the app followed by the name of the model that is set up. There. So you can see the data in there. It's there. You can see the JSON data stored in the measurement. So I thought it would be good to use the JSON-B data type because it's fairly new to get a bit of a play around for it. One of the reasons I decided on JSON is if other guys in the organisation or the group want to send data in and store it, they don't have to get the format deep right. They could just send it through how they wanted in a JSON format, and then we can worry about getting access to it later on. If I just describe that table, it's a fairly simple table. It's got an ID, time it's logged, and a sensor ID, and then the measurement, which is the JSON-B data type. And there's the gen index. If you're familiar with text retrieval stuff, you'll know about the gen index, or generalized inverted index. There's a bit of information there that's worth reading. Oleg Basmov maintains that part of PostgreSQL, and he's got some really cool information on how it works. Now, we have a look. Before I carry on, actually, you'll notice I've created a trigger on here, sensor data notify. So when data comes into here, it's executing the notified data. I'll show you why I'm doing that in a minute. I'll explain now, actually. The first version I wrote, I didn't want to have to write something that was going to poll the database all the time just to see if there's some new values in there, and then trying to graph it. It's a bit of a pain as well. So I started off, had a bit of a query that sort of looked something like that. You can see basically I'm selecting the JSON-B object. Has anyone played around with JSON-B and querying JSON-B?
Just standard JSON.
Yes, there's some new operators and there's some really good methods in PostgreSQL for querying it. There's one of the containment operators. This is actually a shortcut. So you can specify this and then just provide the path down to where you want to go, sensor data, and then type, and that'll get access to the type. But I don't know if this was a 9.6 issue because it's a reasonably new feature, although I thought it should have been a 9.5, but I couldn't use the short notation in an aggregate function there, so I ended up having to use the long format to actually get the value out to be able to operate on it. So I don't know, maybe I just wasn't doing it properly, but if anyone knows the answer to that one, I'd be interested.
Very good try for sure.
Yeah, and it's really cool. You have two functions around the array ags, great stuff together in a single array. So like that, so it just automatically groups them all together into my different types that I got in an array instead of individual rows. So yes, neat stuff in there. I think some of the new 9.5 methods allow you to, because it's a binary representation internally for JSON-B, unlike the old one, it's a little bit slower storing the data, but processing it's quite fast. But then you end up, it doesn't look pretty when you send it out, so there's a lot of new methods that made it available in the new version that allows you to, I think it's called JSON prettify or JSON pretty, something like that. Anyway. So one of the small issues, because I'm using Django, I'll just have a look at the model here, my queen. Some models. To be able to use, to be able to use the JSON-B type within Django, I found this Django PG-JSON-B library, you import the JSON field, and you can use it. That was available like a day or two after the JSON-B data type came out in PostgreSQL, which I just thought was great data. And basically, you just set it to JSON field, and I've said DB index true, and it does the rest. But to put the trigger on it, I've got, so what I wanted to do is set it up and put a trigger on the table so that when data is put in by my worker program, that it would be responsible for telling the client that it's reading the database when there's data there. So as an excuse to use the PG notify and listen functions. I haven't used it before. But I thought, using migrations, how do I do that? So I had a bit of a play around, and you can actually override and specify your own at configuration functions. There's my table there. And then you can call this method here and specify a function name. Moved it over there now. So specify a function name, create sensor data trigger, I've called it, which I've defined in here. And so that's where I've actually created a stored procedure that performs the PG notify, and then the trigger that executes this PG notify on an insert into that table. So what does it do? PG notify now takes two parameters. It used to just take one. So if you're doing a listen and then you got notified that something happened in the database, you then had to query the database. Two parameters. The first one's the channel that you want to use. And in this case, I decided, well, let's use the data rather than having one channel. That way, specifying you on the object, I'm specifying the type as the channel. So I'm going to have a channel of weight, channel of temperature, channel of, and so forth. I thought I'd do it that way because if one of the other members of the society wants to publish their own new sensor data that I'm not doing, like maybe they want to call it wetness instead of humidity, they can do that, and it will automatically be generating the notify, and then they can write code and it'll work. Along here, I'll just scroll along so you can see it. There's just the value. So that's going in the payload. So when it does the notify, it's actually sending the value out there, and I won't have to query the database again. Okay. So that's basically getting the data into the database and a bit of a framework for notifying some client that, hey, there's data here, here it is, for me to visualize it. So the last part of the puzzle, I guess, was visualizing that data in the database. So I played around. Has anyone used, I don't know how many Python programmers do that, used, there's, I think it's called Lightning-viz. So like a visualization server, it's quite cool. Played around with that querying, and then you can actually stream data out to it, and you can just go to it in your browser, and it's got this nice visualization, and you can include that in your web pages and that sort of thing. So as another excuse to play with something else, and I'm not a big front-end developer, but I just wanted to have a look at the data-driven documents. Everyone played with the D3JS Lite? It's pretty cool. It took me a little while to get my head around some of the situations of that declarative programming, because I just the concept at one point of being able to operate on objects within the model before you've actually created them. That's pretty cool. So I decided to go that way, and I've created a page in the application that uses D3JS, and then I'm using PostgreSQL to push the data out, so I don't have to keep refreshing or using some JavaScript Ajax code to go back. But I wasn't sure how to get it out there. You could probably write some Ajax code that you could listen to PostgreSQL, but I didn't get that far, so I don't know if anyone's played around and had any experience with that. But I sort of put an intermediate thing and made use of the Cherry Pie, just like a lightweight HTTP framework, and wrote a little WebSocket server to manage that. So it's called Flow Server, Flow coming from Honeyflow. Here, it doesn't really do a lot, it's really short. There's plenty of examples out there on the internet. And you can see pretty much I just listened to the channels that I want to listen to, and then it goes into a loop on notifies. When it gets notification from the PostgreSQL database that something's been inserted into the table, I pop it off the queue, and I've got the value of notification. I just check I've got a WebSocket connection to the page, and then I'm sending the data across just in the format of a JSON object again. So it has the channel, which is going to be whether it's a temperature, humidity, or noise, and then the payload. So I've actually got all the data I need. I don't have to go back and talk to the the database again. So I might just go to Hive, run up the flow server. So we're actually pushing some data out, and we'll run up the Django app. Hopefully, it'll start a browser. Okay, there you go. So there's a very simple Django app, and there's some stuff there for entering some static data. But then the one I'm set up Hive 2, that's you can tell I'm a newbie at using D3.js, but that's a basic graph that I've drawn there. It's quite cool. The idea, as I was saying before, that there's a sort of optimal requirement, so temperature's 30 degrees. So I've said this is where the reading should be, with the exception of weight, of course. And the further I deviate from this middle area, as it goes red, the worse that is. I know there might be a problem with the hives. And of course, everything's sped up with the test program here. In real life, they're only tiny little bees, and they only carry a little bit of honey or pollen at a time. So it takes a little while for them to sort of create 20, 30 kg of honey. But what it enables me to do over a period of time is correlate these values with how fast the line representing the weight of the honey is growing, and I can see, oh, it's time to rob it, or it's not growing very fast here, and I notice the temperature is very high. It could indicate overcrowding, or the noise might be very low, and that indicates to me that the population's died off. Maybe there's an issue with the bees. So I'll show you the code quickly. It's not really a PostgreSQL part once it reaches this stage. But pretty much there it is, creates the WebSocket connection, and then when it does get that message through the WebSocket, it's basically adding it onto an array, doing a small calculation to get the difference of the ideal value, and then it, once it's got that, it redraws the bit on the screen. The rest of it's all just D3.js stuff. You saw there's the legend there. There's a couple of gradients applied to some rectangles to do the two sides of the boxes. And so that's all based on the scalable vector graphics model. And the documentation's in there great for playing around. It's worth having a look at. While that's going, I'm in my 30 minutes. Probably talking a bit quickly. So basically, yeah, Postgres is controlling the whole lot. I played around a little bit with the JSON-B data type for flexibility. I think, it's got the ability in 9.4, 9.5 to actually update values in JSON, which you couldn't do before. You'd have to delete it, recreate them before. And using listen and notify is a really powerful thing without having to use other frameworks or do polling type actions. So it's pretty cool. Which covered, went through that. Visualization, I was saying Lightning-viz is good, so you don't have to use D3.js, but the two are compatible, so you can do something in between. So, in conclusion, it's a pretty cool tool for doing projects at home, not just commercial apps. It was fun for me to do a presentation on a home use instead of something I do here at work all the time. There's some cool little functions as well. So, time to do some honey. I know you've all been waiting for that bit. So. Anyway, thanks for that.